In this video lesson, we will learn about congruent triangles. So first of all, what do we really mean by the word congruent? Congruency is another way of saying equal, but for shapes instead of for numbers. So for example, these three triangles are all congruent. Why? Because you can shift them and make them overlap exactly the same. Or you can also rotate them and shift them, and they'll still have the same shape. So this is what we call congruent. When two shapes are the same, or more shapes, and the only difference between them is where they're drawn, or how they're rotated. So there are some rules about recognizing if triangles really are congruent or not. The first rule is SSS, which means all three sides of two triangles are the same. So if I give you two triangles and they have the exact same side lengths, those are congruent triangles. And for that, we have to know all three sides. Next is SAS. So the S stands for side, A stands for angle, and SAS means that you know two sides and the angle between those two sides of two triangles, and that they match up. So if I have two triangles and I know they have two of the same angles and the two sides by the angles are the same, SAS applies, the triangles are congruent. Then there's ASA, which is angle side angle. So you have two angles and then the side in between them. If those are the same for two triangles, the two triangles have to be the same entirely. So all the side lengths will be the same, all the angles will be the same, just the same triangles. And we'll talk about this more in the examples that are coming up. And the final method of recognition is AAS. So we know two angles, and instead of the side in between them, we know another side. So one angle, two angles, and we know their measures, but we don't know the length between the angles, but we do know another length. And if we know these three measurements for two triangles, and we know that they match up, then the two triangles have to be the same, or as we call it, congruent. So let's do a few examples to make sure we understand how this works. So the question is, are the triangles congruent? And look, we have a side of length 6 and a side of length 10 that match up, and then the angle between them in both cases is 98 degrees. So yes, these triangles are congruent by SAS, side, angle, side. So in other words, these two triangles are essentially the same. We could rotate and shift them and have them cover the exact same space. So we ask again, are these two triangles congruent? Well, let's take a look. What do we know? We have two angles here, two angles here. The third angle in each case we could calculate. In fact, it's not actually necessary to calculate that third angle, because if you look at all of our possible choices, SSS, SAS, ASA, AAS, all of them require at least one side. And we don't know anything about the sides. Since we don't know anything about the sides, we can't say if they're congruent or not. They might be. They don't look like it to me right now, but in principle they could be. So there's not enough information given. So now we move on to another example, the last one. So this time we actually want to find an angle and a side. So we have these two triangles, and first let's confirm that they are congruent triangles. We have a 6 and a 6, and a 7 and a 7. And in between, in both cases, we have 75 degrees. So by SAS, they are congruent. And then it's side, angle, side, because we have the side, and then the angle, and then the side, all in a row. So now we know that they're congruent. So that means that we can use info from one triangle to fill in info in the other triangle. For example, we know that these two 6s match up and that these two 7s match up for the side lengths, which means that the 8 that we know about triangle DEF has to correspond to the side length of AB. And this is because they're congruent triangles. We've shown that they're essentially the same, so all the measurements have to be the same on both. Now what else can we say? Well, we have 75 degrees and 75 degrees matching up, and 51 degrees, and over here it means it has to be 51 degrees because it's the corresponding angle. And the question is to find angle A, and to find that, all you gotta do is use the fact that the sum of the angles of a triangle add up to 180 degrees. So we add x, which I've labeled angle A with, plus 51 plus 75 degrees. So this is the same as x plus 126 degrees equals 180. So x equals, and we subtract and we get 54 degrees. And that is angle A. It is also angle D, by the way, because the triangles are the same. But in any case, we have solved the problem now. I hope you found this video helpful, and thank you for watching. And here I'm just writing down the answer in final form. I'm going to box it, which is always a good idea. Alright, thank you for watching.